So here's how to find the molar mass of a compound, the mass of 1 mole of particles of a chemical compound. To keep track of the amounts of compounds and reactions, we have to be able to count the number of particles, the number of moles of particles. Most of the substances in chemical reactions are compounds. And so we have to be able to figure out the mass of a compound because the particles, the molecules of the formula units are so small we can't count them, so we have to keep track of the numbers of them by weighing them. To count by weighing, we have to know the molar mass, or the mass of 1 mole of a compound, and we can figure that out if we know the chemical formula. So there are lots of compounds, and we know that any time we see a chemical formula with 2 or more elemental symbols together, that's a compound. And if we can know a lot about the compound based on the chemical formula. And one thing we can do is figure out the molar mass by adding up the masses of all the elements in the formula. So this formula tells us that 1 molecule of CO2 or carbon dioxide contains a carbon atom and 2 oxygen atoms. But it also tells us that if we had 1 mole of carbon dioxide molecules, it would contain 1 mole of carbon atoms and 2 moles of oxygen atoms. And that kind of information we can use if we are weighing things out. So we can look at the periodic table, we can find carbon and oxygen, and we can figure out that the molar mass of carbon is 12 grams of carbon per every mole of carbon atoms, and for oxygen it's 16.0 grams of oxygen for every mole of oxygen atoms. Same number of atoms in a mole of each, but the atoms are different. From the chemical formula, what we can learn is that if we had a mole of CO2, it would contain 1 mole of carbon atoms and 2 moles of oxygen atoms. So we can put those things together. We can use the molar masses of the elements as a factor to figure out that if we had a single mole of CO2, it would have this many grams of carbon in it. And if we had that same single mole of CO2, it would have this many grams of oxygen in it. And when we add those two numbers of grams together, we get the mass of 1 mole of the entire compound. So the molar mass of CO2 is 44.0 grams per mole. We found that out by figuring out how much mass of each of the elements is in a mole of the compound. And we can do this for any compound. We did it for CO2. It turns out we can also do it for this compound KMNO4, potassium permanganate. It contains 3 elements, and to find the mass of 1 mole of the compound, we've got to figure out how much mass each of the elements contributes. Look at the periodic table, find potassium K, manganese Mn, oxygen O. Here are the molar masses. They came from the periodic table. We can use that together with this information from the formula. 1 mole of KMNO4 has a mole of potassium atoms in it, and a mole of manganese atoms, and 4 moles of oxygen. The subscript 4 applies only to the oxygen. So we can use the molar masses of each element as a factor, and we arrange them so that the units of measure cancel out, the moles of potassium cancel out, and we can figure out the number of grams of potassium. Moles of Mn cancel out. We can figure out the number of grams of Mn, and similarly we can figure out the number of grams of oxygen. When we add all those numbers together, all those masses of the elements, we get the mass of 1 mole of the whole compound. The molar mass of KMNO4 is 158 grams per mole. All we needed was the formula and a periodic table. We're not going to do all of these. We'll do one more. Let's try CaNO32, calcium nitrate. What's the mass of 1 mole? Well, it's going to be the sum of the masses of all the elements that are in the compound. There are 3 elements, calcium and nitrogen and oxygen. Every time there's a capital letter, that's a new element. From the periodic table, we can find out the molar mass of each of these elements. We can write it as a factor, which is what we've done here. From the formula, we can find out that a mole of CaNO32 contains 1 mole of calcium atoms, 2 moles of nitrogen atoms. The subscript 2, since it's outside the parentheses, multiplies everything inside the parentheses, and 6 moles of oxygen atoms. The subscript 2 multiplies the subscript 3 to give us the number of moles of oxygen atoms in a mole of the compound. Let's use our molar mass of each element as a factor. Here's how the units cancel out. We multiply to find the number of grams of each element in a mole of the compound. We add the number of grams together to find out the molar mass of the whole compound. 1 mole of calcium nitrate has a mass of 164.1 grams. The molar mass is 164.1 grams per mole. Don't forget that you can go back in this video. You can stop at any time you need to look at exactly what we did at each step of this process for finding the molar mass of a compound. Over and out.